Ladies and gentlemen, I want us in this video together to look at what we call redox reaction, which caters for both grade 12 and grade 11 in physical sciences. So then now, as a learner, you need to know the definition of a redox reaction as to what are we talking about when talking of a redox reaction. So when talking of a redox reaction, we are basically referring to the transfer of electrons, right? Since electrons are being transferred, it means a redox reaction occurs between two species. There's one species that loses electrons and there's another one that gains electrons. Number two, how can you tell that this reaction is a redox reaction? A change in the oxidation number must occur. It's either there'll be an increase in the oxidation number or a decrease in the oxidation number. I'm gonna do this example so that we further assist each other. So for example, if we take this reaction where magnesium in the form of a solid is reacting with 2 hydrochloric in the form of an aqueous, so that we produce magnesium chloride, which is our salt, plus what? Plus the hydrogen gas. So if we are given this reaction, if you are to prove that this reaction it's a redox reaction, what you need to do as a learner, we're gonna dissociate the HCl so that it can split, forming the ions, which is the cation ions and the anions. So when breaking this down, this one will be your H plus in line with Cl minus. Then we've got our arrow. So then now this one, the magnesium, this one, let's keep it like that. The magnesium, this magnesium, it's neutrally meaning you cannot tell as to it has lost electrons or it has gained what? It has gained electrons. So when looking at the MgCl2, when we dissociate it to form the cation ions, it's gonna be Mg2 plus with our Cl minus. So we're gonna keep our hydrogen exactly as it is. From there, we want to check as to where does the increase in the oxidation number occurs or the decrease in the oxidation number occurs between magnesium, hydrogen, and chloride. So the first thing that you have to pay attention to the element or the ion where there is no change in the oxidation number. For example, in this case, we can see that Cl minus, that side we also have what? Cl minus. So the oxidation number of this one, it's -1, and again on our product still it's -1. We can all see that the oxidation number didn't change. It means that as the reaction occurs, then the chloride ions, they are spectator ions, meaning they don't take part in the reaction, because there's no change in the oxidation number. And again, pay attention to neutral element. Whenever the element is neutral, the oxidation number always it's equals to 0. All neutral element, the oxidation number is what? It's 0. It means now the oxidation number of this one, of the magnesium, since it's neutral, it's gonna be what? It's gonna be 0. Secondly, pay attention to diatomic molecules. When talking of diatomic molecules, we are talking of hydrogen gas, which is H2. We are talking of Cl2. We are talking of F2. We are talking of Br2. We are talking of I2. All those diatomic molecules, their oxidation number is 0. So the meaning the oxidation number of this one, it's gonna be what? It's gonna be 0. So then now we are looking at the oxidation number of hydrogen in the hydrogen chloride. So the oxidation number of hydrogen here, it's gonna be +1. That's the oxidation number. So when looking at the oxidation number of magnesium in magnesium chloride, the oxidation number here, it's +2. Now let's check. Mind you, I said to you, we don't entertain the chloride ions because the chloride ions, they are spectator ions, meaning we have to focus on magnesium and hydrogen. So between magnesium and hydrogen, one must lose electrons and the other one must do what? Must gain electrons. So then now, when looking at the oxidation number of magnesium, we can see that we are moving from 0 to what? 2 plus 2. So meaning the oxidation number of magnesium is doing what? It's increasing. And then when looking at hydrogen, we can see that we are moving from plus 1 to 0. It means the oxidation number of this one is doing what? It's decreasing. Then now, that element where the oxidation number increases, that one loses electrons. In other words, since the oxidation number of magnesium increases, it means magnesium is doing what? It's losing electrons. Then now, the oxidation number of hydrogen is doing what? It's increasing. It's decreasing, to say. It means now, this H plus is doing what? It's gaining electrons. Are you guys with me? Hopefully you're with me. So then now, let me write this one. We are saying together, magnesium, it's losing how many electrons? 2 electrons. That's what I am saying. So then now, we are saying the hydrogen ions, now they are doing what? They are gaining what? They are gaining electrons. We can balance our atoms here. As we balance our atoms here, we can put a coefficient of what? A coefficient of 2. Then now, since the magnesium, it's losing electrons, it means this magnesium, it is oxidized, right? Now, since this one, it's oxidized, it means your magnesium will be your what? Will be your reducing agent. So then now, what is a reducing agent? A reducing agent, it is a substance that loses electrons. Or a reducing agent, it's a substance that is oxidized. Or a reducing agent, it's a substance at which its oxidation number increases. Secondly, since this H plus is gaining electrons, we can see, we could say this one has gained how many electrons? 2 electrons. Since it's gaining 2 electrons, it means now this H plus, it is reduced to H2. The ions, they are reduced to the hydrogen gas. Now, since the H plus is reduced, it means this one is an what? Oxidizing agent. Right. What is an oxidizing agent? An oxidizing agent is a substance that is reduced, or it's a substance that does what? That gains electrons. Right. So then now, the substance that is oxidized, it will then give us what we call oxidation half reaction, meaning that one will undergo oxidation reaction. What is oxidation reaction? The loss of what? The loss of electrons. Now, since this one it's reduced, it means this one will give us the what? The reduction half reaction, right? Meaning this species or the H plus will be what? Will undergo reduction reaction. What is a reduction reaction? Reduction reaction is the gain of what? Is the gain of electron. So then now we all can see that this magnesium has lost how many electrons? Has lost 2 electrons. So if you are to indicate the number of electrons that are lost by the species or the element, they are written on your what? On your right hand side. Now, coming to this one, if you want to indicate the number of electrons that are gained by the H plus, they are always written on your left hand side. So we can see that this one is gaining how many electrons? It's gaining 2 electrons. We can see that this one has lost 2 electrons. This one has gained 2 electrons because we are having 2 H plus ions being reduced to H2. So it's going to be 1 plus 1, then it's giving us 2. But mind you, as a learner, you know that you'll be provided with the table, the standard reduction table, where you'll be able to pick all this reaction there. I was just explaining this. So at the end of the day, we can all see that the number of the gain and the lost electrons, they are equal. Now at the end of the day, if one wants to write the net balance equation for this one, you can see this one will cancel with that one. Then it means we are having the magnesium plus 2 H plus, and then our iron, then we are having Mg2 plus what? Plus H2. So basically, this is what is happening when dealing with what? Redox reaction. Thank you for watching. Please follow me for more grade 11 and 12.